This video is going to show some of the capabilities of Autodesk Inventor. First, we will open up Inventor, then we'll open a new part and select sheet metal. While we wait for that, then we will start a sketch and select the plane that we want to sketch in. And we'll start drawing our sketch. To end the sketch, you can either press enter or right click the mouse and click OK. Dimensions are done the same way they're done in SolidWorks, so that's pretty easy to figure out. And once we fully define our sketch, then we will go up to the sheet metal tab and select the sheet metal defaults. The window that comes up gives you a few variables to change. We'll just change the thickness of it. Then we'll select the face tab and select the face we want to extrude. Then we'll open the flange tab and select this front edge and put in the distance we want it to come out. From there, we'll start a 2D sketch and place a point in the upper portion of the part, and we'll dimension it to where we want it. To add a hole, we will go up to the hole tab and change the diameter to 1 inch, and that'll place that where we put our point. Then we can add a couple points to the flange, and we can constrain those similar to the way you would do it in SolidWorks. The horizontal constraint and a vertical constraint. And we'll add a couple more dimensions to it, and after that we will go back to the hole and select the countersunk option there, and then select this down here will give us the option of choosing what kind of fastener we want for it and put that size of hole in it. From there, we'll go up to the shape generator, which is a really cool tool that Inventor has that SolidWorks doesn't. We're going to fix the two fastener holes so that they stay in place, and then we will put a force on the big hole, and you can control what direction and the size of that force, whether it's in the Y or X or Z direction. We will put it in the Y direction as a negative force, so it goes straight down. And then we will go to shape generator settings, where you can specify the amount of mass you want to reduce the part by, and then also specify the fineness of your mesh. Then we'll select the mesh so you can see it there, and then we will select generate shape and run this. Now Cody will talk to you about where to go from there.
Now that we have a suggested shape, the first thing we need to do is promote the shape. This will cause the yellow wire view to come through on our actual part. It looks like the part has disappeared now that we have promoted it, but it's still there in the wire view. The reason for this is because the part doesn't automatically update to the suggested shape. Tracing the suggested part is required so a cut extrude can be used to get the part into what Inventor suggests. As you've seen, the shape generator promoted a shape that you may not have expected. This shape comes from finding the low von Mises stress points in the part and cutting out the amount of material to reach the specified weight reduction, in this case 40%. While the part is being traced out, I will just briefly go over some of the differences between SolidWorks and Inventor. Because Inventor is an Autodesk product, there are short keys to do almost anything, such as create a line by pressing L, a rectangle by typing REC, and a circle by typing CE. In addition to this, some of the features are presented a little differently, such as the constraints for sketches. These are clearly displayed on the sketch bar rather than having to control-click two features to find the same command. This is just one example of Autodesk placing commands in plain sight in the Inventor program. Although they have added various features like the constraints to the bar, it doesn't overcrowd it. This is because they have added features like cut extrude as an option within the extrude command. From here, all we have left to do in this part is make the yellow mesh view invisible by right-clicking the shape generator part 1 and turning visibility off. Change the part to its normal view by clicking the View tab and changing the visual style to whatever your preference is, and finally saving the part, being sure to select the right file location. Now that one part of our pull-up bar is created, we will want to make a new mirrored version for the assembly, but we don't want to go through all the same steps again. So there are a couple of ways to proceed from here. One way to do this would be to mirror the part, extrude cut out the old one, and save the file as a new name, but there's an easier way to do this. If we open up a new part and click the Drive function under the 3D Model tab, it will create an exact copy of whatever part we select. We will now go through the file browser and choose the file we just saved. By choosing the option to mirror the part, we will have created our exact mirrored part in just a few simple steps. You can also easily scale the part through this function too. Once the part is derived, you can easily change the material by selecting this drop-down menu here. Now that we have both sides of our pull-up bar, we will make a new welded assembly by going File, New, and selecting Weldment. Once we have the weldment open, we can easily place the two components we just created into the weldment by going to the Assemble tab, hitting play so we can select our components to add to the assembly. We will add both components to the assembly at the same time by pressing Ctrl and clicking them both and hitting Open. Now that the parts are placed into the weldment, we will constrain them to each other by selecting the Constraint command, selecting the faces that we want to constrain together, and if needed, the distance they need to be offset. This process is very similar to mating in SolidWorks. From here, Jacob will show you the next steps in completing the pull-up bar.
So now we'll make the third part in our weldment assembly by creating the bar. We'll hit Create, give it a new name, Bar for pull-ups, pull-ups, okay. And then we'll select the XY plane and start sketch. Another nice feature in Autodesk is project geometry. We can use this to constrain the sketch of the bar with the size of the hole, so that if we change the diameter of the bar, it'll update with the size of the hole. And we can extrude this to the opposite face on the other bracket, again so that the bar length will update with the offset distance. We'll go to Extrude, 2, and select the opposite face of the bracket. Okay, now that we have our assembly, we can put our welds in. We'll hit Return. Go to our Weld tab, select Welds, and our type of weld, in this case a fillet, and we can select which faces we want to weld. Select the bar, the bracket to weld together, and now we can change our size of the bead. In this case we'll want, looks a little big, we'll do a 0.125 weld. And now you can see our welds on the part. So lastly, we'll add the bolts to our assembly. We can use the Place Imported CAD Files feature, which will open the Content Center, in which we can select countersunk bolts from the Fasteners drop-down menu. Another cool feature in Autodesk is Auto Drop, which comes up when you select a hole for the bolts. Auto Drop automatically selects similar holes on the part so you can drop multiple fasteners in at a time. As you can see, the other hole is highlighted in red. So we'll hit OK. And then both bolts are added to the assembly. And then we'll go ahead and do the same thing to the other side. Select our hole, Auto Drop, and We'll hit OK. So we'll save our completed assembly. Save it as pull-up bar. And now we'll create a drawing. Go to new drawing, create. And as you can see, the layout is similar to SolidWorks, but a little more user-friendly. One of the things that's different than creating a custom view is you can just right-click, select Custom View, and then go in here and it'll take you to the assembly. You can rotate it however you want it. And then hit OK. From our drawing view toolbox, we can change things like view style, level of detail, and scale. Now we can add a parts list to this drawing. We'll select parts list from the annotate tab. Select our assemblies and can go in and change it to, let's see, there we go. Okay, and similar to SolidWorks, we can add balloons and other drawing features.